Right, hello, this is exercise 23, and we will be going over the decomposition rules for all the other operations that we have. So we're going to do numbers 1, 3, and 4 in this lesson. So the first one I have here is if A, then B, A, not B. Okay, like normal, we are going to just first write the set members. So my first set member is if A, then B. And I'm going to write set member. My next set member is A. So I'm going to write A, set member. And my third set member is not B, set member. Okay, so I've written all my set members here, and if you can tell, 2 and 3 are already decomposed. I don't have to do anything with them, but number 1 does need to be decomposed. So let's look over here at our conditional decomposition rule here, and if you notice, it's going to branch off because there's going to be options here, and our options are not P or Q. So I'm going to skip this line and give me my branches, and these can be written in the middle. Here it actually is easier, I just didn't do that this time, but you can do that. All right, so remember, we're going to give our P position variable a negated, so it's going to be a negated A, and our B just stays the same. See how our P gets negated and the Q does not. So I did that, and I did line 1, conditional decomposition rule. And if you can tell that, well, I'm done, so I'm going to check that off. So then I'm going to go back and check each branch and see if there is a contradiction. So I have a negated A, and then there's an A. So there is a contradiction here. Line 2 contradicts line 4. That is a closed branch. Now I'm going to check this branch, B, negated B. So this is also a closed branch. 3 contradicts 4. So both of those show inconsistency. I cannot talk and spell at the same time. Inconsistent. Okay, so neither one of those had an open branch, so I am done with that one. All right, now number 3 over here. Okay, I have if E, then not F, not E, and F. So I have 2 set members here. So my line 1 is going to be if E, then not F, and that is a set member. I'm going to scoot this over better. There. Okay, my second one is not E and F. Not E and F. All right, now remember, we want to first decompose lines that do not branch. It just makes it easier for us. So that's what we want to look for. So we are going to check here. Oh yeah, and we have a conditional and a conjunction. So let's check here. Conjunction, remember, just goes straight down, and the conditional branches. So we actually want to decompose line 2 first there. So line 2 will be decomposed straight down with each variable or constant. So that'll be not E. I used line 2, conjunction, decomposition rule. My next variable or constant is F. So I'm going to put F here. I still used line 2, conjunction, decomposition rule. I'm done with that one, so I check it off so I don't miss anything. Now I'm going to look at line 1. It is a conditional. So looking at our decomposition rule for conditional, it is not P or Q. So this will branch, and remember, it's not branching from the F, it's branching from line 1. That's just where the branches go. So our E gets negated, and our F stays the same. Now it's already negated, so it doesn't change, it doesn't drop its tilde, it just stays the same. Now, for example, if this one was already a not E, it would get another tilde and make it a double negation there. So whatever your variable is in the P adds a negation, adds a tilde, and whatever your Q is stays the same. So it just stayed the same there. So I used line 1 conditional decomposition rule. Okay, so I'm done with that one. I'm going to put a check mark there, so I'm done. Now all I have to do is check my branches to see if they are okay. I have a not E, F, not E. So nothing contradicts here, so that is an open branch. Now I'm going to check here, not F, F. There's a contradiction, so line 4 contradicts line 5. Okay, so even though one was closed, we have one that was open, so we need to get our truth values for the variables there. So remember, I'm not going to write them as a negated anything. I'm just going to write them as a normal variable or constant. And I'm going to look. Now, if not E is true, that means just E is false. It's kind of hard to see that that's the E there. And then F is going to be false. I'm sorry, true. That's kind of confusing with the F there. But yeah, so F, all of our variables and constants we're going to assume are true. So this one would be true. Our F is true there. Okay? All right, so that one is number 3. Now let's look at number 4. I'm trying to move this up here. Okay, number 4. Now this one we have a biconditional. So G if and only if H, not H, G. So I'm going to do my sets first. So my first set is G if and only if H. It is a set member. My second set member is not H. Set member. And my last one is G. So I have 3 in this one. G, set member. Now looking at this, 2 of my set members are already decomposed. Only 1 is not. So I'm going to be working with this line 1. And I'm going to look at this and see where our biconditional decomposition rule is. So now if you notice, this one has like a conjunction ands going straight down, or the negated of each. So on this one, we kind of have a conjunction and a disjunction rule happening there. Okay, so non-negated variables or negated variables right here. All right, so I'm going to skip that line so I can branch here. And I'm going to do my P and Q right here, not negated. And then I'm going to come over here and negate them both right there. Now I'm going to go back and fill in the line here. And this line 4 is line 1 biconditional decomposition rule. And this line 5 is also line 1 biconditional decomposition rule. Okay, so now I am done. So I'm going to put a check mark here. And now I can just go back and see if there's an inconsistency. I have H, G, G, not H. So I have an inconsistency or a contradiction with a not H and an H. So here, line 2 contradicts with line 5. Now I'm going to check this branch. I have a not H, not G, G. So I have a contradiction here too with G and not G. So this one has line 3 contradicting with line 4. So both of those branches are closed branches. So the whole thing is inconsistent. Inconsistent. Okay. All right. So, okay, I had some time, so I went ahead and added this number 5 here for us. All right, so I went ahead and wrote the set, but I'm going to input the set numbers here. So my first set is if J, then not J if and only if K, and that is a set member. I'm going to make some room here. Okay, and then my second set member is not if J or K. Not if J, then K. And it is also a set member. Now what we have here is a conditional and a negated conditional. So what we're going to do is check to see if there's one that does not branch off. So I have a conditional here and a negated conditional. So we want to do the negated conditional first because it does not branch and the conditional one does. So what I'm going to look at is this line number 2, the negated conditional. And oh, I forgot to show you forgot to show you this part. So the negated conditional is P, not Q. Okay, so we need to remember that. So this one will be P, not Q, or K in this one. So K is our Q position, J is our P position. So this is line 3. I used 2, let's see, negated, oh dear, I'm getting ahead of myself here. Negated conditional decomposition rule. Line 4 was also line 2, negated conditional decomposition rule. So I'm done with that one and I check it off. Now I can look here at this one, which is a conditional. Now what does this one look like? Let's remind ourselves. It branches off, not P, Q. Okay, so I'm going to do my branch line, and I'm going to look here. Not P, so it's going to be a not J. And then this whole thing, remember, is like our Q, this whole thing. And it doesn't change, because remember in our rule over there, it didn't change, it just stays looking the same. All right, so this is our line 5, and I used 1, and this is a conditional decomposition rule. This one is already decomposed, so I can actually go ahead and look and see if there's a contradiction. Not J, J. So I already know this one can end. This branch can end because 3 contradicts line 5. Okay, now this one is not decomposed all the way, so this one needs to go further. It is a negated biconditional. Negated biconditional is going to branch, but also have the conjunction lines. It's going to be P, negated Q, negated P, Q. So for this one, it's going to be P, which would be J, or negated Q position, which is our K, or it's going to be the negated, J, or the regular Q. Okay, so our line 6 used line 5, negated biconditional, getting close to the edge, decomposition rule. Our line 7 also was using line 5, negated biconditional decomposition rule. So now everything is decomposed here, so now I can go check for consistencies or contradictions, rather. Not K. Not K. Okay, so this one is an open one, open branch. K, not J, not K, and even not J there too. Okay, so this one contradicts itself. The first one I saw was line 4, contradicting with, where is it? Line 7. Line 7. So that one closes. But this one was open. So what does that mean? We can recover the truth values of the variables. So I have J and I have K. All right, now, let's see, this one was open. Okay, so if not K is true, then that means regular K is false. And and J, just J here, is by itself, and so that one is true because we remember we always assign truth to whatever our variable or constant, sorry, I keep saying that, constant is in our branch here. All right, so we have just decomposed and recovered all of the truth values for those, and that is exercise 23, lesson 23. And I hope this helps, and I hope you can kind of see that this is a lot easier. It's kind of breath of fresh air after what we just did in the last unit. So I hope this helps.